All right, so chapter 1, section 5, we actually get to start talking about the foundation for calculus, and we get to start talking about limits. Um, so they give us a definition of a limit in the very first couple pages of section 5. And so we're looking as we get closer and closer to a specific value, an x value, we get closer and closer to a y value. That's what it means by approaching a value. So as we get closer to an x value, we approach a y value. And that's what this definition of limit stands for. Um, they had a decent picture on page 83. And so as I'm approaching the x value of 1, I'm getting closer and closer to this value of 2. Now, when x is 1, 2 is undefined. I have a hole here in my graph. But still, as I get closer to 1, my y values are getting closer to 2 in both directions. That means the limit of the function as I go to 1 is that y value of 2. So that's kind of the focus of chapter 5, is trying to grasp the idea of limits. Want to look at a few problems in section 5. The first one, obviously if we plug in 0, we'd get a 0 in the denominator, and that would be undefined, and then weird things happen. But we can talk about what happens as we approach 0. So they ask you to make a table, and so you're just plugging in these x values into this function and seeing what are your y values getting closer to. From the left, those negative values, and then from the right, getting closer to 0. The idea of limits. This is one similar to what we just looked at, except these don't have holes. So as I approach 4, so this is 4, 8, 12. So as my x value approaches 4, where does my y value go to? And it's 8, or negative 8, right? As I approach 12, where does my y value go? My y value goes to 0. So it's talking about looking at, as I approach an x value, what does my y value go to? Sometimes it can't be something. Like on a number 3, as I approach a, this value a, right? I think this case is negative 5. Well, from the left, it approaches this b value, right? This height of b. So 3. But from the right, it approaches 0. So these limits aren't going to the same place, and that's why I get a does not exist. So for a limit to exist, it has to approach the same value from the left and the right. This would be a case where it does not. On something like this, if I'm trying to find the limit and as x goes to negative 1, just plug it at negative 1, and it will give you this negative 7/3. Right? So I get negative 7 on top and a positive 3 on the bottom. It's what I approach. But if you look at number 7, as I approach negative 1, well, that doesn't quite work out, right? Because I get that 0 in the denominator. So in something like this, we would have to factor it out. Factor the top and see if those x plus 1s cancel out. Because again, like in the text, I can go to a hole. And that's what happens if something cancels out. You're left with a hole in the graph. So I can go to a hole and have a limit because they both approach the same y value, whether I'm coming from the left or from the right. So sometimes you have to manipulate these things. Same thing happens here on number 8. You have to manipulate. And then also want to look at number 10. This is something where you're going to have to expand this out. So t plus delta t squared. So again, you have t plus delta t times t plus delta t. Expand that out and see if some things cancel out. You should get something nice here. This one I might get started on the supplement as well. So, chapter 1, section 5, we're going to talk about limits. And again, it's this definition. As we get really, really close to some value, Some x value means we have the possibility of getting really, really close to some y value, and that y value is our limit.